So today we will be discussing the problems which contain only dependent source, and then the next move will be to discuss the problem which contain independent sources as well as dependent sources. Now Thevenin's theorem applied to problems containing only and only dependent sources. The trick involved is that now, since there is no independent source, so layman will say, sir, there will be no current, there will be no voltage. Is it clear? Because from your point of view, the dependent source is also dependent on certain voltage and current. And since there is no voltage source or no current source, how can there be Thevenin? How we can apply Thevenin theorem? But mind it, it can have the Thevenin resistance. It can have Thevenin resistance. So how to find out in that case the Thevenin resistance? The concept is very clear. What is Thevenin resistance? The resistance as viewed from the open circuit load terminals. Is it clear? Now how to take into account that dependent source in order to find out RTH? Is it clear? The steps involved is that apply a 1 volt source or 1 ampere current source. This is 1 volt voltage source. 1 ampere current source at the open circuited load terminals. Very clear? Very clear or not? What you have to do? There will be a circuit will be there which contain dependent sources only in addition to the electrical elements, and you have to apply the Thevenin. You have been asked to find out the equivalent Thevenin resistance. What you will do, these are the suppose load terminals. There you will apply a 1 volt voltage source, and let this be current be I0. Let this current be I0. Then RTH will be given as step second. The RTH is given by 1 upon I0. How will you define resistance? Voltage divided by current. And suppose if I give you a circuit and you have to experimentally find out the resistance of that circuit. Say this is a circuit. Let us take an example. This is a circuit. Theoretically, you can find out, sir, what is the value of this? Suppose 1 ohm, 2 ohm and 3 ohm. You say these two are connected in series, this in parallel. Suppose I say experimentally find out, then one method is that you connect a multimeter across the terminals. Okay, it will give you an equivalent resistance, that is the Thevenin resistance. Another experimental method is that you apply a voltage source, measure its value, measure the current flowing through that load terminals. Is it clear? Suppose I applied V and the current flowing is I, then V by I is known as the equivalent resistance as viewed from these terminals, let's say 1 and 1 dash. Is it clear? This is also an experimental method. So same experimental method is being applied here. Instead of any voltage source, for simplicity of calculation, we are applying how much voltage source? 1 volt. Clear? Then RTH is given by 1 upon I0, where I0 we have to calculate it. Or alternatively, I have also said apply a 1 ampere current source. That here you can apply a current source also I. You have to measure V. Then RTH is alternatively can also be written as how much? V upon 1, where I is equal to 1 ampere I have taken. Clear? So that will become your RTH. Is it clear or not?
Yes, sir.
Now, with these two things in your mind, you have to apply this theorem, these steps, finding out the Thevenin resistance for the circuit containing only and only dependent source. Now, sometimes if the resistances are given in kilo ohms, then instead of 1 ampere, I may apply 1 milliampere for the simplicity of the calculation. Is it clear? That you have to keep in mind, and that will set up in your mind by more and more practice of such problems. So let us take a problem which contains only dependent source. Later on I will also tell you that the Thevenin and the Nortons are dual of each other. Dual in the sense, in that case we find out what VTH. In Norton's theorem we will find out I short IN. VTH is nothing, the open circuit voltage across the load terminals. Is it clear? And IN is nothing but the short circuit current across the load terminals. You short circuit it, in one case you open it, in another case short circuit it. The current, then definitely short circuit is some current will be flowing through it. Okay, that current will be known as Norton current. And you will surprise to know that this RTH is nothing but VTH upon IN. This RTH is nothing but VTH upon IN. Okay. So this property is also being utilized sometimes to calculate the Thevenin resistance. So, but we will take this problem later on. Let us take the problem where the circuit contains only dependent sources. So I am drawing the circuit, you draw with me, and then find out the Thevenin resistance. So this is a resistance, this is a only independent sources here. Here another resistance is there, and there another resistance is there, like this. I am writing down the value. This is 1 kilo ohm with polarity plus minus plus Vx. This is 2 kilo ohm. This is 1 kilo ohm. This is 1 kilo ohm. This is 2 kilo ohm. This is plus minus. This is twice Vx. And you have to determine the Thevenin equivalent of the network at the terminals A and B, where these are the A and B terminals. Clear? Now look towards the diagram. What conclusion you are getting? First of all, since there is only dependent sources there, therefore it will only have an RTH. It will only have an RTH. We use the first approach. Let us apply a 1 volt voltage source at the load terminals. I apply here a 1 volt voltage source at the load terminals, and let this current be I naught. Is it clear? So now I can apply any law which is comfortable for me for solution purpose. Now which law so far you have studied will be more comfortable in this problem? I think so, nodal analysis. Do you agree? So how many nodes you are seeing here? How many nodes? 4. Everybody agrees? There are 4 nodes. Let us check it. 1, 2, 3 and 4. Do you agree? Okay, 4 nodes are there, out of which one has to be made as an ground. So let us make the bottom node as a ground node. Now I have to write down, I have to assign some variables to the remaining 3 nodes. Okay, let us assign this as a V1. Now, should I have to assign any value to this? Should I assign V2 here? Or what should I assign it? It is already, how much it is? 2Vx. So it is known, this is how much? 2Vx. Similarly, here I have to assign any value. It is 1 volt. Now, sorry, there is a correction is there, sorry. Where is the duster? This correction is there, sorry. These AB terminals are this much. These are the AB terminals, sorry. These are the AB terminals, sorry. Please make correction, remove this line, these are the AB terminals. Okay? So, this will become how much? This one will how much? 1 volt. Any problem in this? Nodes will remain as it is. There are 4 nodes, one has been made ground, and the remaining values we have already only one unknown V1. This is 2Vx and this is 1 volt. Though it is also unknown in the name of Vx. Is it clear? Now what we will do? Apply KCL at this node. Let us apply. How much you are getting? So it is how much? V1 minus 1 upon 1 into 10 raised to power minus 3. Clear? What else? V1 minus twice Vx upon 2 into 10 raised to power minus 3. What else? V1 upon 1 into 10 raised to power minus 3. Any more branch connected to the node V1? No, this equal to 0. Who is creating problem? Vx. Can we remove Vx? What is the value of Vx? Yes, speak out. V1 minus 1 equal to? Sure? Everybody agrees? Oh, no problem. You have to just start from here. Start from here. Or start from here only. And apply KVL. Those who are in confusion, how much voltage is there? V1. How much is there? So I am starting here. This drop will be like this. So it will be how much? V1. Do you agree or not? Now I am making a loop. I am making a loop. Okay. Negative positive. Previously it was negative positive, so it will become V1 plus Vx. Okay, no problem. Positive, negative. So how much it will come? Minus 1 equal to 0. So I can write down V1 plus Vx is equal to 1. Are this is clear or not? Okay, so Vx will become how much? 1 minus V1. Equation number 2. This was your equation number 1. Okay. Substitute the value of Vx in equation number 1. All the terms will be, unknown terms will be in the name of V1 only. So we have one equation, one unknown, solve it, how much you are getting. Give me the result fast. Solve for V1. And then tell me what is Vx. How much you are getting V1? Give me in fraction. Give me in fraction. 2 by 3. No. Yes. What is 4 by 7? V1. How much? How many people are getting 4 by 7? Only 4 to 5 students. Are you getting V1 as 4 by 7 volt? Yes. Are you getting V1 is equal to 4 by 7 volt? If not, improve your mathematics. Improve your arithmetic portion in order to grasp the fundamentals of circuit theory. Else you are in danger. So definitely Vx will become how much? 1 minus 4 by 7, that is 3 by 7 volt. Is there any problem up to so far this? Now we come to know about the two voltages V1 and Vx. Can we find out? Now what is this I0? Let this current be I0. Let this current be I0. This current will be sum of these three currents or not? Do you agree? Okay. Can you find out all these three currents? Can you find out all these three currents or not? What will be this? Let this be I1, let this be I2, and let this be I3. What is I3? 1 volt divided by 2 kilo ohm. 1 volt divided by 2 kilo ohm. So therefore I3 you will get 1 upon 2 into 10 raised to power minus 3, 1 by 2 milli. What about I2? I2 is nothing but 1 minus twice Vx divided by 1 kilo. Do you agree or not? Okay, so I2 will become how much? 1 minus twice Vx upon 1 into 10, this is minus 3. Vx is how much? 3 by 7. So it will become 6 by 7. So it will become 1 minus 6 by 7 milliampere. That is how much? 1 by 7 milliampere. So I2 you have got how much? 1 by 7 milliampere. Any problem so far? What is left? What is left? I1. So how you can find out I1? 1 minus V1. 1 minus V1 upon 1 ohm. So I1 is nothing but 1 minus V1, and V1 upon 1 into 10 raised to power minus 3. So V1 is nothing but 4 by 7. So it will become how much? 3 by 7 milliampere. Any problem? So you have got I1, I2 and I3. You just add all these three quantities. I is equal to I1, I0 is equal to I1 plus I2 plus I3. That is how much? Half plus 1 by 7 plus 3 by 7 bracket milliampere. So when you solve it, you will get 14 plus 2, 16, 16 plus 6, how much? 22. So total answer is 22 by 14. So when you solve it again, it will come out to be 11 by 7 milliampere. Any problem this? Any doubt in this regarding this question? No? So you have got an idea. Yes? Any calculation difference you are finding? No? It is clear to all? Okay, so the concept is very clear that whenever there is an circuit containing only dependent sources, then you have to apply either a 1 volt source or 1 ampere current source, and then so this is the current. This is what current? I naught. I have to find out what? I have to find out what? RTH. I have to find out what is the question being asked in the problem. Find out RTH. So RTH will become 1 upon I naught. 1 upon I naught. So my RTH will become how much? 1 upon I naught. I naught comes out to be how much? Yes. It is how much? 15 by? How? If you take LCM 14, then 7, oh it is 7. 7 plus 2, that is 9, plus 6, so it is 15 by 14, no problem. So it is 15 by 14 milliampere. Okay, let me correct myself. It is some calculation mistake was there. It is 15 by 14 milliampere. So RTH will become 15 by 14 milliampere will become 10 raised to power 3 in the upward side. So 14 by 15 kilo ohm is the Thevenin resistance of the given circuit, which contains only dependent source. Any problem up to so far this? Okay. Now next we take a problem which contain both independent as well as dependent sources. So let us write down that problem which contain now in such type of problem where the circuit contain independent as well as dependent sources, what we do, though I haven't dictated about the Norton's theorem, but I have to apply both theorems, Thevenin theorem and Norton's theorem. Since with the assumption that you have learned Norton's theorem in the lower classes, so you know in the Norton's theorem instead of VTH we calculate IN or I short circuit. Is it clear? So with this assumption you know this fact, I will give you the steps involved in the circuit containing both independent as well as dependent sources. In that case you find out VTH also and you find out I Norton also, and then you say that the RTH is nothing but VTH upon IN. You got my point or not? Is it clear? So though I haven't discussed about the Norton's theorem, but with the assumption that you have learned in the lower classes, it is clear that the circuit containing both dependent as well as independent, you have to calculate both, you have to find out VTH as well as IN. So let us take one problem first of all and then see how it can be applied to the circuits. So this is my dependent source is there, resistance is like this, independent source, again some resistance which are connected in parallel and in series form like this. So this is the circuit. I am now writing down the values. This is 2000 IX. This is 1 kilo ohm, this is 2 kilo ohm, this is plus minus 12 volt, this is 2 kilo ohm, this is 1 kilo ohm, and this is 1 kilo ohm. 4 by 3 kilo ohm. So now I will draw the Thevenin equivalent circuit with a voltage source in series with an current source, in series with a resistance RTH. Now Okay, our objective was not the Thevenin equivalent, our objective was to find out V naught. So I am drawing the Thevenin equivalent. Now in the question where nothing output load resistance is not given and you are given simply an open circuit terminals and asked to draw the Thevenin equivalent, then do draw this Thevenin equivalent in the last, in this way. But here in our problem we were having a load resistance also. What is the value of that load resistance? How much it was? 1 kilo ohm. So 1 kilo ohm is this much. How much is this? 4 by 3 kilo ohm RTH. This is your RTH. This is your RL. And what is this much? This is VTH. How much value is? Mind it is minus 6 volts. So the polarity will be not plus minus. It will be minus plus. You got my point? You have to be very careful. And you will be careful when you are knowing the fundamentals about the polarity sign of the voltage and the direction sign of the current. So definitely how much will be the current? IL will be equal to how much? IL will be equal to how much? How much? VTH upon RTH plus RL. So 6 divided by 4 by 3 plus 1 into 10 raised to power minus 3. So when you solve it, it will come out to be 18 by 7 milliampere. But what was your objective? V naught. What was your objective? V naught. Now this current is flowing in this direction. Your V naught is this much with this plus sign and this is minus. Is it clear or not? But your current is flowing like this, so this became plus and this became minus. So whatever is V naught, just reverse its sign. V naught will be definitely drop across 1 kilo ohm, but current is flowing opposite in this direction, so this will become plus and this is minus. But in our question, V naught has been described as plus on the upper side and minus on the negative side. So my V naught will be nothing but minus 1 into 10 raised to the power 3 multiplied by 18 by 7 into 10 raised to the power minus 3. This is cancelled, so I am left with minus 18 by 7 volt. This is very clear or not? This problem is clear? Okay, so what I can understand that now it is very clear that how to handle the problems containing both dependent as well as independent sources. And this is a typical problem which contains not only Thevenin theorem, not only Norton's theorem, but also nodal analysis, and in addition to the super node concept is also there. Clear? So if you have understand this problem, I think so 50% of the circuit theory fundamentals is clear to you. If not, that still you are in danger. That's all for today. In the next class, we will take the Norton's theorems.